this video, we're going to go over network protocols. Protocols are rules for how devices communicate and send data over a network. So basically, protocols are a list of rules. There are lots of different protocols that you need to know about. We're going to do IP and MAC addresses first. IP addresses are unique identifiers for devices that are sending data between networks. IP addresses are assigned to the device before it accesses the network. IP addresses are made up of numbers, and each time your device accesses the network, it might have a different IP address. There are two versions of IP addresses, IP version 4 and IP version 6. IP version 4 uses 32 bits. But it became very apparent very quickly that this wasn't enough to accommodate all the devices trying to access the network, so IPv6 uses 128 bits. IPv6 uses hexadecimal to represent the numbers, and these are split into 16-bit chunks. IPv4, on the other hand, uses denary numbers, and each number is split into 8-bit chunks. MAC addresses, on the other hand, are unique identifiers for network-enabled devices on the same network. MAC addresses cannot be changed. Each device on the network must have a unique MAC address, otherwise it would get confusing. So if, for example, you send a request to the printer, your computer, which will be identified on the network through its MAC address, will send a request to the printer, which is identified on the network by its own MAC address. So as far as the network is concerned, everything that is connected to it is a series of letters and numbers, not names. This is why it's important that everything has its own unique identifier. This is how the network traffic knows where to be directed to by the router. The other network protocols that you need to know include TCP/IP. This is the protocol that says how data should be sent between networks, and this includes the internet. The TCP stands for Transmission Control Protocol, and this is the rules for how the devices connect together on that network. Any data packets that are being sent across the network are split into different chunks and then put back together into the original data packet once they have been received. TCP is in charge of checking that the data is sent and then delivered correctly. IP, or Internet Protocol, is in charge of directing packets to the right place on the network. This is why it was important that the IP address is a unique identifier so that the packets end up in the right place. When it comes to the internet, there are even more protocols that you need to know about. HTTP stands for Hypertext Protocol. HTTP is used by web browsers to access websites on the World Wide Web and communicate with any web servers. HTTPS stands for Hypertext Transfer Protocol Secure. This is a more safe, encrypted version of HTTP. So any data that is sent via HTTPS will be encrypted, making it harder for hackers to access. FTP, or File Transfer Protocol, is used to edit and move files between devices on a network. So this is what would be used if you were on a device on a network and you wanted to access files from the server. POP3 stands for Post Office Protocol version 3. It is used to get emails from a server. However, the server will have the email on it until you download it, and at that point, once you have downloaded it, the server will then delete the email. IMAP stands for Internet Message Access Protocol. This is similar to POP3 in that it is used to get emails from a server. However, the server will hold the email forever until you actually delete it. When you access your emails, you are only downloading a copy. This is the most common email format used on the internet. SMTP, or Simple Mail Transfer Protocol, is used to send emails. Network protocols are often split into layers. Layers are groups of network protocols that have similar functions. There are 4 layers that you need to know about. Each of the protocols in each layer don't interact or know what is happening in the other layers. So a level 1 layer is things like Ethernet. This is used to pass data as electronic signals over the network. This layer can communicate directly with the layer above it, layer 2, which is IP. This is used to make connections and transmit any data between networks. The layer above that, layer 3, is TCP. This checks and sends that the data is being sent and delivered in the right order for the packets. And then the 4th layer is HTTP, HTTPS, FTP and SMTP. And these protocols are used for turning data into websites or apps and programs and vice versa. The main reason that layers are used is that it breaks any network communication down into smaller pieces. This means that it helps people who are trying to develop things concentrate only one area of the network and they don't have to worry about the other parts. Any parts of any layers can be changed and the other layers won't be affected, and having these standards also makes it much easier for companies to make things that will work across any device. Standards are agreed requirements for hardware and software. By having standards for each layer, it forces developers and companies to make things that are compatible regardless of the manufacturer. So if, for example, you bought an Apple phone and then also bought a Samsung phone, if the layers and protocols didn't have standards, then you would need one set of websites for accessing on an Apple phone and another set of websites for accessing on a Samsung phone. So software developers have to develop apps for Apple phones, apps for Microsoft phones, and then apps for Android phones. This is time consuming and tricky because it's multiplying the amount of work needed on the software developers to get it out across the different platforms. Standards were developed to try and reduce this problem. However, Apple are quite keen on having their own standards for different things, such as the charging cables. This is good for Apple because it forces people to buy more and more of their products. So if you have an Apple phone and it comes with an Apple charger, you're then more likely to upgrade to an Apple phone again because you can carry on using the same equipment for it. Phones that run on Android, though, tend to use common standards that are compatible with multiple different devices. Android phones tend to be charged via micro USB cables or USB-C cables. These are not a standard of Android devices. Most devices will be charged using this type of cable. It's that Apple decided to do things differently in their own way, presumably to get more money out of people. Think about Ethernet cables and USB ports. These are standards. USB works in any kind of computer device because it's an expected standard that everyone should use.